Hey guys, how's it going? So I know this video feels a little bit clickbaity, maybe a little bit extreme, but from my point of view, like that's totally merited. And my hope is by the time I'm done, you'll at least agree with me in some areas that AI seems to be heading off a cliff. In terms of progress, that we're coming up against a wall that's going to prevent further fundamental breakthroughs. Now, first caveat is I'm kind of shooting from the hip here, so I'm not editing. You'll see my eyes darting towards my notes, which is just to keep me on track. Yeah, so I'm only going to do this in one take because I've got a lot of stuff to do, but I really thought this point is worth getting out because I don't feel a lot of people are talking about this, especially with the hype that's being generated in this latest wave. So to sort of get started is specifically that experts sort of think of AI in terms of waves. They usually term things like the AI winter. So over the past 60, 70, 80 years at a push, AI has had massive impacts in academia, which then resonates into the public sphere, that coasts for a while, and then it dissipates, it plateaus, and we have a period of remission before it comes back when there are new ideas from academia, which then generates new engineering breakthroughs. And it kind of just goes like that. And, I've experienced this directly. I've been working in AI for about 2 decades now. And about 15 years ago, round about that time, there was a big breakthrough from Fei Li or Li Fei, and she made this breakthrough in MNIST datasets where recognizing numbers using computer algorithms to recognize numbers. And at the time, that was like ridiculous because prior to that, you'd hear all the if else jokes, and people considered AI as just being massive logical strings of decision trees. But she was one of the, not the first, but the first major impact in the public to show data driven AI could basically, absolutely outperform and smash all of the AIs prior to that. So we've done really good, like in the past 20 years, from new, like all of the neural network stuff, which I kind of see her in my mind as like one of the core, the flags, if you want to think of as like the milestones in my mind that have kind of led to this growth in neural networks. Um, Obviously, there's lots of people like Andrew Ng and Nick Bostrom and huge contributors in the space. And so about 20 years ago when I got into it, I would say about that time, the idea of data was not really taken seriously in business, finance for sure, and data would be synonymous with database devs, so development, not really business things. They worry about keys on a table and things like that. But when deep learning and neural networks and stochastic gradient descent, these terms can hit the public conscience, huge events globally started to crop up where new companies were marketing themselves to finance and tech and public space and governments, saying that they could drastically overhaul their services with new data-driven neural networks. And it took about as long as it took cloud to be imprinted on the conscience of the average project manager or the average person in the street. And it's done really well. And there's lots of services out there like fraud detection, anything that's when you get a loan, or a lot of visual recognition software. There's a lot of stuff out there that's kind of based upon neural networks, and that's done really well. But then it plateaued, right? Like because it hit the limits of data-driven services, right? Like it was always the edge cases that they struggled with, like where you couldn't really generalize if you don't have data on something, so you couldn't build neural networks for that. And so before LLMs, just this period of about 2018 to 2022, there was re-emergences of logic driven and decision tree driven AI, like that more rules based, right? Because that was coming back into the sphere, and people were thinking maybe we have a rules based model that encapsulate a data driven model, and that way we can cover all bases. And that was looking quite good, but also it was still pretty limited, right? So if that doesn't really make sense, a lot of the stuff I'm talking about, effectively what I'm trying to say is AI had in this most recent wave, the second last wave, was the major one that impacted budget, right? Like this came into the space, everything from Netflix to Amazon, they all implemented it. And that looked fine, but then, people were still thinking more wider in terms of AI, like the future could be any kind of thing. It could be, it doesn't necessarily need to be neural networks. And then what happened was LLMs came out, and attention is all you need. I'm not going to drivel on of all of that sort of stuff, because if you know what I'm talking about, then you don't need me to explain it. And if you don't know what I'm talking about, then I'm going to focus on the points that matter. So your chat GPTs, your Bings, your Llamas, your Bards, your Anthropic AIs, these are all large language models, right? Effectively in the background, they're forms of neural networks that work on trying to predict the next sentence. And how they can actually implement that to make it useful is when you ask a question, what's happening in the background is it's taking your question and trillions of data and sentences and trying to like generalize what the next words would be, and that would effectively be the answer. And then what's happened is this is taken by storm, because OpenAI hit a critical point of data. They'd gathered enough data that they could pretty much predict what anyone was going to say, right? Like all the conversations had kind of happened online, and they'd sort of, in my opinion, they'd stolen data illegally without our permission, but they built a great product, right? And then they commercialized it. And this is where we are right now. So where we are right now is we have these like really powerful AIs that are able to predict the next sentence. Now, what happened is, and what you're seeing to happen is anything from Minecraft to like economics to like things that don't appear to be related to text are all piggybacking and leeching off of these LLMs, because you can ask an LLM like, where do I find the start, the start task icon in Windows, or the command line, how do I open DOS, or how do I open terminal, how do I do this? Like, it can give you not just the answer in English, but also, like, because so many people have asked, it has a kind of understanding of like visual relationships. So it's not just understands what to say, it understands what to say based upon what you see, right? And a lot can be done with this, right? So you can have LLMs put into games so that they can help people build better scenarios, build better AIs to navigate stuff. It can write code for you, and so it's done really well. So it seems like everything's going great, right? But the issue here is that, again, LLMs, just like neural networks in the past, with your MNISTs, your CNNs, so image neural networks, or RNNs, language networks, all of these, your GANs and things like that, all of these rely on data, right? And what we've effectively done is OpenAI have stolen enough data that all of the engineers can piggyback on that and make new products. And so what's really happening is the growth has only just begun, but the fundamentals has completed, right? There is no more fundamental research on these LLMs. They're nothing meaningful. There's some improvements and optimizations. What we're now seeing is we're seeing the coasting of progress, because whilst academia always is ahead of what you see outside on the street by at least 20 years, maybe sometimes, at least 10 years, maybe 20 years. So there's probably another 6 years left of growth of LLMs before they get boring, right? So you're going to see some really amazing stuff. I think there's so much it's really hard to keep up with, but that will run out. And sure, they are going to, like, the improvements they offer will be at least double or triple what we saw in the 2010s and the late 2000s, where we had, we no longer needed rules-based fraud engines. We no longer needed really complex systems to predict parts of the weather or to evaluate if fruit is ripe or not, right? Like, we could do that with neural networks, and the same is happening with LLMs. We're going to get at least double, triple, maybe quadruple the amount of value in the world than we saw in 10 years ago. But that value is coming from the engineers who are like really creative with open source stuff and they're creating all of these new products, these like real life chat assistants that they're not like chatbots of the past. They can do anything, and so this is great. But it'll end and it'll come to a close, and it'll come to a close whenever you try to do anything novel, right? So this is the prediction that I'm making, and I'm certain it's true because I've been doing this for years and I've been ahead of the curve, especially on LLMs. What will happen is LLMs will really finally complete the bullshit of automating the boring stuff, right? And anything from even maybe call center work, you might even see that as the final implementation. Like real call center automation with LLMs is totally possible, and people think that's tomorrow. It's more of an engineering challenge. It's probably more like 3-4 years. Think of how hard like a big company takes to build out a product like that. It's probably about 3-4 years. It's the engineering, it's not the AI. But when that comes to an end, what will happen is things will quickly stagnate, right? So you're going to get to a point where you can't really engineer any new tools because they've already been done. You might get a little bit, it'll be more like brand and value for money and quality. If it's been anything from automating accountants, automating architectural elements, or automating your checkout work, your study assistants, or they're going to be more human related stuff. So stuff that we couldn't do 10 years ago, there'll be a lot more stuff that feels super but still finite, right? It's just more human interactive automation. And when that runs out, you'll find that a lot of the stuff that was really onerous is kind of done, but then all of the creative stuff or all of the new work that comes on top of that. So it doesn't necessarily need to be creative, it just needs to be new, right? Like new areas of work, new fields of expertise where these companies haven't had the ability to grab that data as regulations clamp in. So you could think of like new streaming fields of like influencers or new economies. Drone development, right? It's going to grow hugely, and there's going to be much more impact of drones in your daily life, from deliveries, robotics and things like that. And LLMs will not be able to help as much in them because the regulations are clamping down that OpenAI can no longer steal that data. So in 10 years, once drones have been everywhere, there'll be huge fields of expertise that you can't just Google and you can't just chat GPT. You can get it to maybe make guesses and build some basic generalizations, but nothing will be a specialist in those areas. And maybe new forms of accounting as well, and new forms of driving and whatever. So when that happens, sure, like we could just say open the gates and just absorb that data and then automate it again. But you'll always be chasing the curve. You'll never be ahead of the curve, right? And for anything to do with fundamental logical thinking, that's going to be hard, right? So again, the argument people make is like ChatGPT and Claude and things like that, they seem intelligent, like they seem like they're reasoning from first principles, but they're not. What they're doing is they're abstracting on information they've already got in language. It doesn't, these models don't actually have a physical understanding of what's going on in the world. There is there's a what we call an embedded abstraction of the physical world, but it's not dynamic. It can't flex and change if you give it new things, or if you apply new rules that are outside of its data set. It'll have a go. That's better than nothing. Like it'll try to have a go, but it'll be completely nonsensical, or it'll sound legit but actually is really dangerous because it doesn't know what's right or wrong, and it can't make, so these AIs can't make logical deductions. When you read them, that's reason for this logically, they're not reasoning for it logically. They're getting all of the words that have been said and it sounds sensible, and a sensible person might say there's reason for this logically, ABCD. It's a very sophisticated parrot, but it's not a fundamental thinker. And so this maybe seems like I'm a bit of a hater, so it might feel like I'm throwing stones for something that is massively going to change the world, and it will. But I kind of feel I have to use an analogy which is really really close to my heart, and I think really tells the story here, right? Is there's a book called The Three Body Problem, and it's written by Liu Cixin, a Chinese author, and it's considered the Star Wars of China. It's a massive franchise. It's huge. If you've not read them, give them a go. They're mind blowing. But there's a part in the story where effectively there's these aliens that have been made aware of Earth, and they basically want to destroy us, and they see us as a threat. And they're much more advanced than us, but they're far away. So one of the things that they do is they realize that they can't just hit us with a laser or something. So the only and they're panicked because our rate of development is really fast. So what they do is they send out these things called sophons, which are like protons, but with circuitry written in them. And these protons lock down our technology. And what it does is it prevents us from making new fundamental breakthroughs, right? And so they know that if they can prevent, what they do is they go in particle accelerators, like multitask. So whenever we try to make fundamental science breakthroughs, we smash atoms together, these sophons interfere with the results in a statistical way that's far more complex, because they've got far more compute, and fools us every time. So we can no longer dig deep into the atom, and we can no longer make reasoned explanations about things that we don't know about, maybe gravitons, the string theory, things like that. And so they know by doing that, even we think we're making progress, we're not. Because they know once they lock out our fundamental technology, Earth still makes massive breakthroughs, right? We work hard, and eventually make fusion, and we eventually get these starships, and we kind of laugh at them. They're like, oh, they can only go at like 4% speed of light, and we can go at 20% speed of light. So it feels like we're more advanced. But the minute just one of their probes enters our solar system, it destroys the entire Earth armada of like thousands of ships, because it has a technology we don't have, which is strongly interacting matter. And this probe, it just destroys the entire fleet. So apologies if you've not seen it, but the point being is we were kind of overconfident because our engineering had made up for the lack in fundamental breakthrough. So it felt like we were really advanced. It's like we'd honed really perfect arrows, we'd made the perfect swords, we'd made like the most efficient medieval armor. Still doesn't compare to a tank. And this is where I see the world of LLMs and neural networks. Like, it feels like fundamental research has been locked out, because we've been chasing this obsession of neural networks and data-driven AI for the past 20 years. Like nobody could potentially consider any other alternative. People laugh at rules-based engines now because they're like, well, it's all in the data generates the rules, and there's no more critical thinking behind that. It's more just, how can we optimize, how can we better improve stochastic gradient descent? And nobody's considering a world without the data. Like as problems get harder, right? Like, it becomes harder to obtain that data. Like as we enter the race of evolutional medicine, where we're trying to build the next gen of antibiotics, in some cases we only have very small limited data sets of what those potential future viruses are going to be. And sure, we can generalize, and sure, we can use LLMs to build tools, but those tools aren't going to be useful in areas that require novel thinking and creativity and fundamental research, right? And so what will happen is you'll feel the mundane, like the stuff that's kind of medium hard will become mundane and will just be done. But the stuff that you actually need to do will become extremely hard and will be back to the drawing board. So this is where I kind of feel LLMs are going, and neural networks, because they're, again, it's like we've locked out the fundamental research. This is such a good tool. It's absorbed most of academia into just creating better versions of what's out there. And this is an issue, right? Because again, I go back to most of the most important problems are problems where we lack sufficient data to make a decision. And so there are other ways to solve an issue than just having all of the data, or at least approaching the data problem in a different way. And so Yeah, I mean, it's really hard for me to kind of it. I appreciate it's like a 20 minute, maybe feels maybe like a 20-minute rant, depending on how you see this. But my point I really think is important is we need to get back to fundamental research. We need to go away and say, okay, how do we create intelligent systems? Let's look at the brain again. Neural networks don't model the neural networks of the brain, not at all. They're completely different. There's some, it's like similar in spirit, right? But not in reality. I mean, the neural architecture of your brain, of your cortex, your limbic system, the spinal cord, the evolutional process into how your brain evolved is so more complex and abstract and so much more hidden material that we don't know yet. So this neural networks that we consider, that was that Witten and his guys invented, was more of like an homage, like it was like a tribute band. And so I feel like things are going to be really exciting for the next 3 or 4 years, maybe a bit like the crypto wave. But then really quickly, once those applications are dried out and once companies, set their market base and they monopolize those areas, there's going to be very little to do in that space. And then when all of these new things come through, it's going to be harder for people to apply those tools to generalize the new things. So like when the new things come out, you can't just go, I'll apply the LLMs again because of all the legislation. And again, even if you did, forgetting all the copyright issues and all of the issues of data protection and your right as a person, like even if we did do that, you're always just going to be chasing the wave, and to build out those products takes time, and we're constantly creating new material and new ideas and new forms of work. So it's just not a long-term solution. It's a long-term solution for tooling, like for tooling of stuff that's pretty well known. Like it's a really good solution. It's a nice, better thing than we currently have. So I guess it's kind of hard to wrap a point on that, right? Like it's effectively what I've said. They're great, but they're limited. And they're limited because we're not really making fundamental breakthroughs. And we're not making fundamental breakthroughs because the students aren't really interested. There's all of those experts are gone now. They're all dead, right? Like those people who had daring ideas, they've been like laughed out of academia because their stuff maybe didn't work as nicely, but had more long-term potential. I mean, you talk to any AI specialist, they could talk your ear off about what variants of neural networks are useful, of the diffusion models and things like that. It's not just LLMs, it's diffusion models, generative AI, basically. And they excel in their trade. Like they become a good maybe a good artist, but they're not Van Goghs, right? Like they're more like a designer, right? They'll design your product, but they can't architect the future. They can't set the trends. They can't carry the wave of the cutting edge of what future is going to look like. They just are really good at what they do, but they're not good at building the next thing, and this is part of the problem. So we're in an engineering phase is effectively where we are. Like we're in a phase where like you make a lot of money, right? Like you do really well if you invest your efforts and time building out automation of LLMs, and you do really great. So if you're a DevOps engineer, sysadmin, or just somebody who has some good ideas, you can build great things with LLMs. But for the long-term humanity to solve like these really big problems of like global warming and fusion, I think maybe genetic issues, the evolutional medicines, I think they're gonna fall flat. Like we've heard things with DeepMind with their breakthroughs, but they're not creating drugs, right? Like I've not bought a drug from the shops, or I haven't had any even small bits of news that this is going to lead into big pharma. That may lead into something eventually, but right now there's no big breakthroughs, and I don't think there will be. I think these things are going to plateau pretty quickly, and the romance period is going to pass. So to move forward, we're going to need people that maybe go back to scratch, right? They think of new ways to generate intelligence. Think of intelligence in different ways as well, right? Like ethics first, emotions first. Think of things like the wider part of human society as like as being intelligence as being more decentralized and more pervasive might be one approach. And try not to think of things too much in terms of like clusters of networks, because that's only one facet of intelligence. So I realize I've kind of ranted a little bit now, but hopefully you kind of got a flavor for what I'm saying. And I'd be really eager, like if you totally disagree, and I'd love to hear your ideas, and even I can address them, or I do another video and address them, or we do a joint video or something. It's not as if I'm like a major player in this space in terms of being popular or anything. So it's more just a conversation. So I'm always up for that. And yeah, thanks for watching.